Welcome to SS2 Chemistry, Term 3, Week 5. Organic chemistry covers compounds of carbon. In this lesson we study the unsaturated hydrocarbons, alkenes, double bond, and alkynes, triple bond. They are far more reactive than alkanes and form the basis of the plastics and polymer industries. By the end of this lesson, you will name and write formulae for alkenes and alkynes, describe their bonding and structure, explain their key reactions including addition and polymerization, distinguish them from alkanes, and answer WAEC questions confidently. Let us begin. Alkenes are unsaturated hydrocarbons with at least one carbon-carbon double bond, C equals C. General formula, CnH2n, for one double bond, no rings. The double bond consists of one sigma bond, strong, formed by head-on overlap of orbitals, and one pi bond, weaker, formed by sideways overlap of p orbitals above and below the sigma bond. Pi bonds restrict rotation around the C equals C bond. This gives rise to geometric, cis-trans, isomerism in some alkenes. Naming alkenes, IUPAC replace the "n" ending of the parent alkane with "in", number the chain so the double bond gets the lowest number. First 5 alkenes, ethene, C2H4CH2 equals CH2, simplest alkene. Propene, C3H6CH3, CH equals CH2. But 1 in C4H8CH3, CH2, CH equals CH2. But 2 in C4H8CH3, CH equals CH, CH3 exist as cis and trans isomers. Pent 1 in C5H10CH3, CH2, CH2, CH equals CH2. Structural isomerism in alkenes, but 1 in, but 2 in, and methylpropene, 2 methylprop, 1 in, are all structural isomers of C4H8, same molecular formula, different structural formulae. Physical properties of alkenes, similar to alkanes, gases at room temperature for C2 to C4, liquids from C5, immiscible with water, less dense than water. Slightly higher boiling points than corresponding alkanes because pi electrons make molecules slightly more polarizable. Alkenes undergo addition reactions. The double bond opens and 2 atoms or groups add across it to form a single product. This is in contrast to alkanes, which undergo substitution reactions. Hydrogenation, the addition of H2 alkene plus H2 alkane, requires NECO catalyst at 150 degrees Celsius. CH2 equals CH2 plus H2CH3, CH3, ethane. Industrial use, margarine production from vegetable oils, hydrogenation of C equals C bonds in unsaturated fatty acid chains to produce solid fats. Halogenation, the addition of halogens alkene plus X2 dihalogenocane, room temperature, no catalyst needed. CH2 equals CH2 plus Br2 CH2 Br, CH2 Br, 1, 2 dibromothane. Test for unsaturation, bromine water, orange-brown, decolorizes rapidly in the presence of an alkene, C equals C reacts with Br2, alkanes do not decolorize bromine water in the absence of UV light. Hydrohalogenation, addition of HX alkene plus HX halogenocane, room temperature. CH2 equals CH2 plus HCl CH3, CH2Cl, chloroethane. Markovnikov's rule for unsymmetrical alkenes, the hydrogen adds to the carbon with the most hydrogens already attached. Example, CH3, CH equals CH2 plus HBr CH3, CHBr, CH3, 2-bromopropane, is the major product, not CH3, CH2, CH2Br, 1-bromopropane. Hydration, addition of water alkene plus H2O alcohol, requires phosphoric acid catalyst at 300 degrees Celsius and high pressure. CH2 equals CH2 plus H2O CH3, CH2OH, ethanol. Industrial process for making ethanol from petroleum-derived ethene. Polymerization, many alkene molecules, monomers, join together to form a long-chain polymer. Addition polymerization, no small molecule is expelled. NCH2 equals CH2, 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 N, polyethylene/polyethylene. polychloroethene, PVC, from chloroethene. Polypropene, polypropylene, from propene. These are thermoplastics, can be remolded on heating. Alkynes are unsaturated hydrocarbons with at least one carbon-carbon triple bond, C is identical to C. General formula, CnH2n2 for one triple bond. The triple bond consists of one sigma bond and two pi bonds. The carbon atoms involved are sp hybridized, and the molecule is linear at the triple bond. First 5 alkynes, ethene, C2H2HC is identical to CH, also called acetylene. Propyne, C3H4CH3, C is identical to CH. But 1-ine, C4H6CH3, CH2, C is identical to CH. But 2-ine, C4H6CH3, C is identical to CCH3. Pent 1-ine, C5H8CH3, CH2, CH2, C is identical to CH. Ethene, acetylene, is the most important alkyne industrially. It is produced by the reaction of calcium carbide with water, CaC2OS, plus 2H2OL, C2H2G, plus CaOH2AQ, or cracking of hydrocarbons. Uses of ethene, welding and cutting metals. Oxyacetylene flame reaches over 3000 degrees Celsius, hotter than any other common fuel. Production of polyvinyl chloride, PVC, precursors, synthesis of many organic chemicals. Reactions of alkynes, similar addition reactions to alkenes. They can add 2 moles of reagent across the triple bond, forming first a partially reduced product, then a fully reduced product. Hydrogenation, HC is identical to CH plus H2. CH2 equals CH2, ethene, CH2 equals CH2 plus H2 CH3, CH3, ethane. Halogenation, HC is identical to CH plus Br2. CHBr equals CHBr, then plus Br2 CHBr2, CHBr2. Comparison of alkenes, and alkynes. Alkenes, CnH2n plus 2 saturated, single bonds only, react by substitution, e.g. halogenation under UV light, do not decolorize bromine water without UV light. Alkenes, CnH2n unsaturated, one double bond, react by addition, immediately decolorize bromine water. Alkynes, CnH2n, 2 unsaturated, one triple bond, react by addition, 2 moles of reagent possible, also decolorize bromine water. WAEC question patterns on alkenes and alkynes. Draw the structural formula of a named alkene or alkyne, identify the type of reaction, addition, polymerization, write balanced equations for addition reactions, apply Markovnikov's rule, state the industrial importance of addition polymerization and name examples of polymers, test for unsaturation using bromine water. Distinguish between cis and trans isomers of but 2-in for higher level questions. Cis-trans isomerism in but 2-in, cis but 2-in, both CH3 groups on the same side of the double bond. Trans but 2-in, CH3 groups on opposite sides. These isomers have different physical properties, different boiling points, because their molecular shapes are different. Key points: alkenes contain C equals C double bond, general formula CnH2n, react mainly by addition. Alkynes contain C is identical to C triple bond, general formula CnH2n2, react by addition with up to 2 moles of reagent. Test for unsaturation, bromine water decolorizes rapidly, orange-brown to colorless, with alkenes and alkynes, not with alkenes. Key addition reactions of alkenes: hydrogenation, plus H2, N-catalyst, alkane, halogenation, plus Br2, dihalogenocaine, hydrohalogenation, plus HX, halogenocaine, Markovnikov's rule, hydration, plus H2O, H3PO4 catalyst, alcohol, polymerization polymer. Markovnikov's rule, H adds to the carbon with more H atoms already on it. Ethene, acetylene HC is identical to CH, produced from CaC2 plus H2O, used in oxyacetylene welding. Addition polymerization of ethene, N, CH2 equals CH2, 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 N poly, ethene, very important industrial process for plastics.